question for you guys first. What did Tori go over in terms of like search and binary search, linear search? You guys know.
He went over recursion ones, but he didn't like. He never broke down binary search or anything.
So do you know the difference between linear and binary? Should I go
there?
Yeah. Did you know the
Why not? Sure.
Alright, I'll just go. So for a sorted array, we have these numbers. The way a computer looks at this is if it's looking for 3, it's going to start from the beginning and literally try to match each value and see if that value matches. Otherwise, it's going to look at 1. Does that match 3? No. 2. Does that match 3? No. 3. Does that match 3? Yes. And we'll just stop at that. So that's linear because it's straight. Binary is, like I said, let's keep the same one. Binary means having. So it would have this array. And look if the value is on the left-hand side or the right-hand side of where it had. So if it is, say we're still looking for 4, we have that 3. 3 is the center, such copy. We would only look at this portion of the array because we know the value doesn't exist on this side. And then we would do it again until we only have one other place to look, and if that number is the target. Okay, that's really it. So that's binary search in a nutshell. So Sean's gonna.
Did you guys understand that? Yeah. Did you show them the already circled and all that, like that would.
Where are you trying to go? Yeah. The important part of binary search is if we're looking for the index of the target, we can't affect the array. Because if you destroy the array, if we start taking out values and saying, all right, well, we're looking at a smaller amount of numbers, that's affecting the index. So we have to figure out a way to look at only here without destructively affecting this array. So that's what we're going to show you. All right, so start with binary search. We're going to take 4 arguments. First one's going to be the target number.
Well, but before you do it, how many arguments would you take if you were doing this? I don't know how many people solved this and how many people did not solve this.
I got pretty close to solving it.
I did it with 4. I'll say.
And who doesn't understand why you need 4? Because I did not understand.
4 arguments?
Yeah, AJ, you all understand why you need 4 arguments and not just 2.
Would you mind explaining that?
The way they set up the RSpec is there was like a number and then an array of numbers, and that was very confusing.
Right, you would want, and it says in the challenge to take 2. It shows you a thing where it takes 2 arguments and not 4. That's where it gets a little. You can't do this with 2 arguments without destroying the array, which is then impossible to find the index because you've destroyed the array. How do you know what the original index was? So when you're looking for something in a binary search, you need these 4 arguments, and we'll show you what they are, in order to look without destroying the array. Yeah.
Wikipedia saved me so much time. Like, I would not have. I would have like banged my elbow against the wall if I hadn't looked at that Wikipedia page.
That's the trick. Yeah, that's. So sometimes there are tricks like that. So yeah. So
They do,
just
they
wanted to
throw
make
you-
sure we.
They'll throw you a loop, like they'll say like this is what you need and then it's actually not what you need. They want you to search for it yourself and find it yourself.
Yeah. And that was the single biggest thing that I did not understand was what these 2 other arguments are. So ask questions about them if you don't. It still took you a
That's
very long
confusing
time.
because I don't even know I'm supposed to be asking a question. Like I'm getting stuck and I don't even know that I'm supposed to like.
Right. So, alright, sorry, I just want to make sure we all understood what the 4.
Right, so the 2 arguments that they provide you with the target and the sorted array. This won't work if the array.
Does anybody have any idea what the other 2 arguments could possibly be?
The high and low index so that you're searching it, like the portion of the indexes of the portion of the array that you're searching.
So why do you know why you have to do that?
I don't remember because I did that and I'm looking at it right now. I can't remember why I needed them.
So
I know that I did.
the reason you need both a min and max is because we're kind of changing the scope of where we're looking. And that's why that's kind of like the trick of making this non-constructive. Because if we could potentially check the length and divide by 2, but then we don't know kind of where the start of the new array that we're looking for is. Even though it's not a new array, it's just kind of like if I need to potentially make this the minimum. If this is the new array is 3, 4, 5, I need to know that this is the new min. So that's why we have to do that.
Yeah, because these are gonna be the values that you're being destructive on without destroying your original array. So you need something that needs to change, so these are basically gonna be like almost placeholder variables that you're gonna be able to destroy while also keeping this array intact, which is the most important thing to finding the index.
Whenever you do an equal sign in the numbers there, in equals 0, that sets the default value to 0. I'm sure someone's even that confused. That's
Julie, can you speak louder?
oh yes.
And do you guys understand the part that why we're setting those variables to values before we even start? I don't know how far you've been in week 1 if you talk about setting default values to arguments. Have you guys done that at all?
So it's like if you don't pass an argument in, it's initialized with a value.
Right.
That way you don't get an error if it doesn't have a min to begin with.
Right. So you understand that, like, before we even start, we're saying the minimum's always 0 from the, like, when we start, it's 0, and it'll be the length or size of the array that we're looking at. Before we even pass anything in. We don't have to pass those 2 arguments in, because those will be our starting arguments for that. They're going to change.
Right, yeah, that's necessary to use the recursive method for this, right? When you call it again, you need to be able to pass in new min and max.
Right. You don't want to call a recursive method without a new argument changer. You know, you can, but for this, you want to be able to change them. Does that make sense?
Cool. So with any recursive method, there is a base case, which pretty much is we're going to keep doing this method until a certain condition is met. And I think the first condition was actually provided for you in your reading, which is return -1 if that target does not exist in that array. So what Sean's doing right now is saying return -1, sorted array, value, first value, and the only value in that array is not equal to the target. Also, we have this part. If the value, I'm sorry, if the length of that array is 1, so there's one value left where we're looking, and that single value does not equal the target. So that's our first base case. Just FYI, whenever you do a return, and it hits that return, it will stop the program. And that's why the returns make for great base cases. Next part is,
Just real quick, do you guys know what a base case is? Everybody knows, because I didn't really understand the concept of a base case right away, so like.
I would like to understand like what's a good process for figuring out what your base case is? Like when people
That's a great question.
I did one of the weekend challenges and I used base case. It's like, what's the easiest, most basic way to solve the problem? What's the,
So yeah, I mean, let's do it for this one. So like, in the challenge it says like if you don't find the number, return this. So we're only returning -1 because that's what the challenge told us to do. We can return anything. Does that make sense? So you start with what you need to return at the end, or if conditions don't pass. That'll be like the first hint to what your base case should at least start with. And then you just want to think about, sometimes it's hard to do your base case right up front. Sometimes it's not so easy to do it this way. But in this case, we know that if we get to the end of that array, and that number is not even in the array, then we need to make sure that we stop this code from running over and over and over, because if it just keeps looking, it's going to run forever. You guys seen Stack Overflow?
a lot.
Yeah, you're going to keep seeing it forever. It's like the biggest mistake we all make. So you just want to know, like, you want to just think about, like, well, how am I ever going to get this program to stop running? Like, when do I need it to stop running? And sometimes it's not so clear, right? You're not going to know right away all the time.
That's another way to word your base case. Like, what's the condition of the program stop?
That's a great way to think of it.
right, so the next part of the algorithm that we talked about, like binary search, is splitting that array in half, not destructively, but looking at that middle number and kind of getting a feel of, is that number less than or greater than the number we're looking for? So we have to find min. So the way we do that is we actually get the min, add it with the max, and divide it by 2. That's going to be the middle index of the middle number, the middle value. Which kind of brings up another base case, right? So what if that first value that we found is the number that we're looking for? So let's create another base case. So return that middle number if that value isn't target. So we get that?
So you can have more than one base case?
No, it's, a base case is probably not the best term for that. You have one base case. At least for what we do. Maybe there's something we don't know about, very possible. But like for what you guys want to think of it, you have one base case. It goes at the top. This is just like, what if you get lucky and the number you're searching for is actually the middle number? You know, like, so we want to pay attention to that, like, because I know when we wrote it, we forgot that part, so it was never find it. Like, if the number was in the middle, if we were lucky enough to hit the middle number, right, or at any point during our search, we need to make a condition for that as well.
Well, it's like yesterday, or I guess the day before, when Tori was doing like the test driven development, and he was writing like the simplest thing first. Like our base case is, I guess, technically our simplest situation, which is just that our number's not in there. So like that's like your first, like, okay, like this is a layup, this is one thing that if this happens, like we'll get this happen all the time. And then when you start writing the method for how like sorting through and shrinking your array, that first number you get is like would be the next easiest thing to find, because you have to get it to move the scope. You have to know where the middle of it is, and so that's why it's like it would be like the next. Maybe easy isn't the greatest word to use, but that's like the next most simple option you have for finding your target neighborhood.
Right.
So I guess that's just how I thought about it.
Yeah, and you just want to make sure that you're paying attention to all possibilities, right? If it's greater than, less than, or equal to in this situation. And before we move on from the middle, because this is something I didn't really know either, you guys know what happens if it's an odd number? Can you bring up pry?
Do you drop at the floor?
You don't, see with integers you don't have to. That's the thing.
I don't have it automatically.
It always rounds down with integers.
If you divide by 2.0, then it's returning.
And it'll give you a float. But in this case, you don't, yeah, obviously you don't want to do that, because you want to, so it'll always, yeah, so in this case, it's doing, to find the middle, it's going to find, that was going to find 5 divided by 2 is 2.5. It's going to treat this as the middle, or 0. Yeah.
Do you guys use pry?
Actually, that was really
Always
simple.
IRB, that's not sure.
I think I installed it.
This is position 2, so this
What's the
treats this as
difference?
the middle.
Pry is a debugging tool. It's basically the same as IRB, only it has a little bit more, you can manipulate more what you're actually looking for.
It's colorful.
It's colorful, you can put little spots inside of Pry
Yes.
that you can like debug from. It's really useful. There's a lot of documentation on it, so ask Tori. It's just a gem. Install Pry.
I just installed it.
You just type in Pry.
Yeah, gem install pry.
And that was the command I found.
Oh, you
Make
might
sure
have
you
to might have to
refresh.
restart your
Oh,
browser.
right.
Yeah. And actually, I was just working with Chris yesterday, and he was showing me that you can there's another gem for Pry where you can actually have like Ruby docs in your terminal that you can access when you're offline from Pry. It'll just show you.
Did someone make that here? Is that the one someone made here?
The gem.
Ruby doc gem one?
I don't know.
Alright, so who doesn't understand this concept? Can I just be
It's
honest
okay to
if you
not
don't
understand.
Like, because
Should we show them the debugging part of Pry?
I mean,
I think we should just keep going with this. If we have time later, we can show it to them.
Alright, so on to the recursive part. So we're going to make a if-else conditional. So if that middle number that we're looking at, if that's greater than the target, we know then to look on the left-hand side of that array. So before you write the min and max, does anyone know what's going to change in the parameters here? So we're calling this binary search method again, but for recursion to actually work and not go on an infinite loop, the parameters have to be different, or else it's just going to be doing the same thing over and over. So what would change here if the middle number is greater than the target? Say we're looking for 4. We got to 3, or I'm sorry, for 2. We got to 3.
your middle becomes your min.
Your min becomes your middle.
Your min becomes your middle.
Well, so we're
What's our target number?
so our target number in this case, let's say our target number is
You have to be.
is 2, right?
Oh, okay. So the middle becomes our max.
Right.
Mhm.
Yeah, that's right.
So
That's right.
it's
So
confusing. I'm
yeah.
very confused. The target is 2. Yeah. So now we just want to look here. So this is when the min and max come important, and you can start changing it without destroying the array.
Right.
Makes sense.
Or we want to look on the left.
Yeah, you want to go on that.
We don't want to look there.
We're changing the place we look. It gets confusing. Look somewhere else. That's the most important thing to take away from this. And that greater than and less than sometimes gets very confusing.
Yeah.
That's it.
So what is the final output? They want the location,
index,
the index
Yeah.
of your target.
Yeah. Now, if you weren't looking, if they wanted the number itself, which wouldn't really make
It's already
sense,
giving you the
then you
target.
could destroy the array.
No.
But if you want that index, you can't destroy the array. That's what's important.
So how do you return the index? Where is that?
Return is here. Return middle. If you go into a binary search, your target is always gonna land on the middle index. If you set it up this way, unless you do it greater than or equal to, which is still working in this case. But the thing is, if you look into one side of the array, if you keep like going, how to say, if you keep looking at a small portion of the array, you'll find that your target is always gonna land on the middle, right?
Yeah. Like, so even if you're, in the only
Okay.
case that it wouldn't, it'd be when there's one left.
One left and then that's your thing.
And we made that condition, then that is your middle.
Yeah, your
It will
middle,
return.
min max goes the same thing.
Yeah.
Oh, okay. And
Yeah.
middle's not the value, it's the actual index, yeah. Okay, cool.
That's it. That's binary now. In a nutshell.
Well, that was easy.
Recursion is really, I don't know, for me it's really nuts. Like, it's really hard to really wrap your head around.
You know, it took me with Fibonacci, like, I had such a hard time, and then, I think Liam, you helped me with that. Like, we drew a tree,
Yeah.
a binary tree.
Yeah, the
Then
only way that
finally it started to.
like recursion could make sense to me is like physically drawing the tree
Yeah.
of all
Oh,
possibilities
yeah.
to get down to like the base case and then adding across.
Yeah. Or to actually like draw out your entire method and plug it in
Yeah.
will help too as well. You know what I mean by that? Like, actually when you're returning it to like just make this crazy long method on a piece of paper to understand what you're actually plugging back in and where it's gonna go. It seems ridiculous, but it really is helpful to understand what you're doing when you're calling a method again and again and again and again.
For the weekend challenge, which we had a recursion, I did that in combination with the base case, and I got done in like 45 minutes. So it was like those two skills to put together. Otherwise, I did that in 3 hours.
Yeah.
So.
It helps to like visualize.
Yeah.
What other questions do you have about this?
Yeah, I'm just curious as to when we're recursively calling binary search, why are we passing in 0 for like
You
in that
could
case
you
rather
could
than like min again?
Okay.
You could, alright. Because like if you have like a really long array and like it's in the right half, but then within that half it's in the left half, would you you know, I just that's what I'm saying. Passing in array size again seems that's confusing me.
Well,
Rather than passing in max there.
Yeah, you could.
Okay.
I don't guess I don't understand.
No, so online 10, he's saying, why did you do sorted array dot size?
Okay. Keep it consistent.
Oh, that is, yeah.
Hey, okay, so one of the last release we had for that binary search challenge was to manage to find the index inside a really, really large array. It was test array was the range of 100 to 200 converted to an array. Oh shit.
Go ahead. Yeah.
I just want to see how y'all managed to make it. I couldn't understand why mine wasn't solving that, and I was just getting a stack of overflow every time I tried to solve it.
Usually your first instant, like the first thing you should think when you're getting Stack Overflow is there's something wrong with your base case. It doesn't know when to stop. Like, usually, like 9 times out of 10, your problem is there.
Yeah.
Like you're not writing in a stopping, like it's not stopping ever. Even if it was wrong, it should still stop. If your base, like even if the rest of your algorithm is
fucked, you should still stop at some point.
Yeah.
Yeah, I learned that from Courtney. So, did you write it?
Yeah, it takes a while.
Anytime you're using recursion, it usually takes the computer a little bit of time to think.
That's a great thing. Did you guys know that? Like, recursion takes longer than loops.
Yeah.
A lot longer.
And
uses more memory.
Usually, when there's some form of recursion, there's usually another way to do it that is a lot less taxing on the computer.
So then, when are we going to be using it if an iterative method is usually
You know, it's an interesting question.
Actually, well, so you
Because I haven't used it since this challenge.
So,
I don't know when you will.
Oh, I'm sorry, I can't
Sure,
hear you.
those are cheese.
did you look at release 2 of Sudoku?
Yeah.
So you need recursion back, because at some point, you have to
It was,
make
I
a
sat
test.
next to Neil.
You have to save that state, go through the entire program, see if it solves it. If not, go back and then do it again. Guess a different number. That's recursion. So this you have to do it.
And what we hear is that it might be an interview question somewhere or somewhere, just so you understand the basis of how it works. Will you probably use it while making web apps? Maybe not.
Probably not.
But
However, it is like a really big interview question. This is one of the
it's
most
really
asked ones.
I guess it just shows that you understand what the computer does or can do.
Does, and the math behind it.
yeah. Like your whole first week is basically can you not can you solve every problem, but can you deal with make a plan, see it through, and not like
Yeah, and concept.
Yeah.
Concept.
so.
Are you guys pseudocoding a lot?
Yeah,
I try to-
more and more.
It's, as the weeks go on, pseudocoding becomes increasingly more important. Like, the challenges you'll get in the end of this phase and then the next phase, you need to sit down and figure it out.
And
You
if it's
need
not,
to-
if it's not pseudocode, it can be like pseudo.
It could be
So
any,
it's like,
something to outline what you're gonna do.
Yeah.
Because otherwise, just creating and hoping it all clicks, it's not gonna actually work.
When we were doing, what were we doing? Sudoku, yesterday and today, it's like we just start to like come up with solutions and implement them, and then you do that 4 times, and then you forget the first one you tried, and you loop back around, so you get so far away from the problem, you
Yeah.
don't even know what you're doing. So it's like you gotta stop it and like.
The pseudocode's most of the work too, right? Like
It
you
is.
thought it through. All you have to do is go.
Yeah, like Sam taught us, there was a teacher here named Sam, he put it like
It's amazing.
perfectly. It's like literally write out every single step. It's gonna look almost like code sometimes. Every single step. Like don't even think yourself, oh, we'll figure that out when we get to code. Like that's what we all do, and it's really that way. Just like when you're going over to do the coding process, you should literally just be translating into code what you've written. Like all your classes should be laid out, every algorithm should be laid out. You can test things and try in an IRB while you're pseudocoding to understand if that's really going to work or not. And literally, it should take you like 20 minutes to go from your pseudocode to your code, because you're just literally copying the ideas of what you've done.
Yeah, RJ and I were in a group working on the flashcard project. We spent like a couple hours actually writing out the pseudocode. We literally wrote out each method, and it took us like I think a little over half an hour to.
It took us almost a whole day to do the pseudocode.
That's okay too. Like that's a big thing too. Sometimes
What?
you might see
That was
other
an
people
actual
coding
word.
around you, and you're still doing pseudocode, and you're gonna be like, "Oh man, I'm taking too long on this." You might be, but you probably aren't. You know, it's okay. Like you want to like get it all out in pseudocode
Saves some
first.
time.
It will.
It's kind of like doing the test cases first. Like it takes longer to set them up and write them out, but then once you start coding, it's like a downhill. You know, things are working. You know what's breaking. You know faster.
Cool. So, any more questions about this, or you guys want to do some enumerable stuff?
Yeah, we were really cool.
Cool.
Mike, you gonna do it?
Yeah.